everybody. My name is Yvonne Gunreben from the Federal Ministry of Transport and Digital Infrastructure from Germany. My topic today is how the bridge management system in Germany works. And normally I'm working at the Ministry for the Department of Civil Engineering Structures, and I'm the deputy head of our department. Dear ladies, gentlemen, dear colleagues, I'm pleased to present the bridge management system in Germany today. My presentation is not only about the pure management of bridges or structures, but rather about the embedding of the management system in the entire maintenance cycle, as well as the associated strategies for maintenance. Therefore, I got some main topics on my agenda as some background information and statistics from Germany to give a small overview of our infrastructure. Then I will get into the BMS, and above all, I go into our inspections and basics for the database. Furthermore, I would like to show how the BMS is embedded in the maintenance strategies. And I will give a small outlook on what is currently concerns us in the bridge inspection and thus also in the management. We at the ministry are responsible for the federal highways. You see the red lines, and for the federal trunk roads, the blue lines. As you see, we have a tight network of roads and, of course, a high density of bridge structures along and across our roads. In the middle and south of Germany, in particular, we have a higher number of valley bridges due to the topography with the edge of the Alp in the very south. The flat coastal regions can then be found in northern Germany. And in the east, you can see the federal highway ring around Berlin. Well, what concerns us? At first, the necessity of reliable infrastructure for economic growth. We have an aging infrastructure to deal with, the increase of traffic with volumes and loads, ensure efficient, safe, and socially and environmentally friendly mobility. Sustainability, maintenance, and development of transport system is an issue. And we have to consider of climate change, sustainability, and resilience, as you see on the right-hand side. That's our age contribution. We have two peaks. Up here, you see the building activities after the Second World War in Western Germany. And the second peak, shows the construction activities in Eastern Germany, mainly after the reunion of Eastern and Western Germany. Well, most of our bridges are built of pre-stressed concrete. You see here the blue area. And we have about 13% of steel and composite bridges. Why is that? So if you look at the length distribution, it quickly becomes clear that our proportion of really long and large bridges is not that high compared to the large number of smaller bridges. But of course, this also has to keep in mind for maintenance, which brings me to the actual top of the bridge management system. Here you see the definition of bridge management system from the OECD, which is still valid today. On the left side, you see all the information which is needed and the basic for any assessment and analysis with leads in the end to different possibilities, such as a maintenance program. Well, let's take a look at how we try to implement the requirements for a management system and what our objectives are. Our basics, our goals, based on results of bridge inspection. We need early information about the deficits and the future behavior. We want to optimize everything based on damage of bridge components, and we have to consider of direct and indirect costs. Indirect user costs, for example, these are economic costs or the consumption of carbonization if there are traffic jams and detours due to construction sites. So our claim is the same approach for all bridges in all federal states, and optimization on object and network level, the consideration of financial and quality criteria, the consideration of follow-up actions. Yeah, and the result should be that we get different levels of maintenance action. Here you can see the overview of the various modules of our BMS. On the top left, you see our main part of the bridge database, which I will report in more detail in a moment. On the right side, highlighted in green, you can see a macroeconomic evaluation at the object level. Bottom left in yellow, we have the economic optimization at network level. Well, let's get back to our main part. There are a few regulations for doing this. So first of all, our standard of bridge inspection, yeah, it's nearly 100 years old, still updated till today, but yeah, we're doing bridge inspection more than 100 years. Then we have our guideline for recording and assessment of damages, and the basis for all the basis for our database is the inventory instruction you see down there in blue. And yeah, for sure, you need some more guidelines. We have a guideline for recalculation, for maintenance, and a strategic planning of maintenance. So first of all, in our standard, we got requirements for bridge inspection like condition detection, fixed periods of repetition. They should be comprehensive, reproducible, systematically, and for sure, objective. Well, during the inspection, you check the different bridge components. Therefore, in our guideline for recording and assessment of damages, we have the distribution in bridge components, such as substructure, superstructure, bearings, and so on. And all leads to a damage assessment regarding stability, traffic safety, and durability. At the top right, you can see the calculation for a damage of durability at level 1 from the guideline. All ends up in a condition index for the total bridge and its components. On this side, we have an example for the assessment of structural stability from 0 to 4. So 0 means there's no effect on the structural stability, and 4, yeah, maybe the structure no longer exists when you have a flood or something like this, or yeah, a very, very hard accident, this might happen. All ends up, as I said, in a condition index from 1.0, 1.4, with a very good structural condition to a inadequate structural condition when you have a grade of 3.5 to 4. So what do we do with all the information and the results from the bridge inspection? You put it in a database where all components of a bridge are integrated. Our program called the Bauwerke, which means Road Information System Part Engineering Structures, you can see up here. And part engineering structures means that we have an information system also for the roads itself, where all the dates are implemented, and also the pavement condition index, for example. Why call we it engineering structure? Well, with this tool, we are also able to manage tunnels and noise barriers, for instance. So you see here my older desktop version, but nowadays we have a web version. You got also an app for mobile devices to integrate data and photos for the bridge inspectors. Yeah, here you can see how deeply the database is structured. For instance, you can search for the designated type of bearings, as you see the red cycle on the right-hand side. So what's the benefit? Maybe you know that this type might have a systematical failure, so you can filter all bridges and you know where you have to show after. That's really an advantage. Here you can see on the next 4 slides the different levels of the database system, so that you can hopefully imagine what information has been stored about the structure since its construction. So we have here now the name of the bridge, authority, internal key, and so on. So we are going now to the substructure. This means, well, in the federal highways, we often have two bridges, one for each direction. So up here, then we would have one for the one direction and a two for the other bridge for the another direction. Yeah, what do you see? You see the name, the kind, the type, the stationation, authority, the owner, the year of construction. And down here, you can go to the inspection reports, some other facts, drawings, and so on. Well, let's have a deeper look for a description of a damage. That's only an example. You see the pavement with some cracks and the assessment of of stability, traffic safety, and durability, for example. So we also have a nice summary, a nice overview. So you see the main facts on one slide. I found it very easy that you have the main facts, and also, as you see here in red, the grade, the condition index, and some facts like length, width, area, angles, and so on. However, every database is only as good as it can fed with high quality data. Since inspections are very important in Germany and the quality of inspection is important to us, we founded the Association for Promoting Quality in Education and Training for Inspection Engineers about 15 years ago. If you need further information, don't hesitate to visit the website. Let's come back to the other components of the bridge management system. Based on the knowledge of the bridge stock, one can now go there and link it, for example, with maintenance measures and cost restriction. So you can create maintenance strategies. You come from damage to actions. You can calculate direct cost or duration cost. Yeah, that's really nice to have. And here you can see the same thing on a macro level, which converts the whole thing into cost. And this makes it calculable. So the owner costs are the costs we have, but these are not all the costs, because there are more costs for the users, like costs by dithering and so on. For example, we had our program developed for our Rhine bridges in metropolitan areas, big bridges over the Rhine. And the program calculates the best procedure sequence for renewing bridges in a certain area. This is important because you don't want to paralyze all the traffic, nor do you want all the traffic drive through the middle of the city. So the program gives you the best sequence, which bridge has to be renewed. So, you know, the first bridge in this year and the 10th bridge, I don't know, in 15 years, something like this. So you got a sequence. Here we have the next slide. Well, because of course you have to see the whole thing against the background of quality and budget and not neglect the transport network. So this brings me to a maintenance program. Overall, the BMS should then find itself in a life and maintenance cycle. As you see up here, there's the bridge management system, and it's in a cycle up here. And you see it's very important to update your bridge data. Then you have your inspection. The data is also can be updated by recalculation and so on, so that you have really a good base. With us, the individual maintenance program is embedded in a strategy that is adapted to the respective situation. Basically, we move between 3 different optima, which can be different depending on the situation and network. I want to explain this briefly on the following slide. So in our guideline for the strategic planning of maintenance, we will find 3 different scenarios. The first one, strategy 1, with preventive maintenance. I give you a small example. It comes into play on busy section of the highway network. Here I said fixed maintenance cycles. For example, I got a road section to maintenance every 15 years so that another section is available. I then exchange all expansion joints, for instance, even if some might have lasted another 3 to 5 years. Number 2, reactive maintenance is particularly effective in the secondary network of federal trunk roads and on sections of the federal highways with little traffic. Here I'm a bit more flexible with regard to traffic. I don't necessarily have those long sections and can focus more specifically on the individual structure. Number 3, targeted aging. Well, it's less for the federal trunk roads than for the subordinate network. Since roads and bridges are in municipal hands, the costs are particularly highly important, so that maintenance is carefully considered. A blocking in a subordinate network is usually not that much of a problem. So I summarize the whole thing again. For us, bridge stock database is essential. We come from damage to maintenance strategy with cost and duration. We consider of each relevant damage at each bridge components. We have to consider of maintenance recommendations. We are implementing all in a maintenance strategy and for sure the calculation of future behavior. So that's the basis for optimization at object and network level. Yeah, I would like to give you a little outlook. In order to support the management of structures, there are, of course, many ideas that either have a direct impact on the inspection or in the long term accompany the management in an increasingly digital way. However, all of these innovative procedures should bring a benefit and not mean additional effort. So what are the advantages? Well, we must create them with regard to accessibility, time and cost savings, comparability with previous tests, reproducibility, reduction in traffic intervention, and reduction of manpower requirements. So, and then you can fulfill it in the specification, of course. Yeah, drones can certainly be helpful here. But, well, you know, they are not useful for every damage. And the boundary condition also has to be recognized, like when it's too windy, you can't use them. Likewise, monitoring is getting more and more important, not only for critical bridges where you're monitoring a crack, for example. We are also in the process of equipping bridges with clearly defined monitoring system right from the start in order to test whether we can use them to obtain longer inspection cycles with the same level of security. But there's still a lot of research to be done here. Even you have to deal with all the dates, datas, and the lifespan of this equipment. Yeah, and our researchers are using non-physical modelings, and they are now looking for artificial intelligence. Well, let's see what science will bring us here. And of course, building information modeling is also a big topic for us. Structures that are planned with this method and processed on a construction site should then also be stored later in the maintenance with a building information model in the database. Well, nowadays, we know a paper plan or microfiches last over 100 years. But can we read the dates of BIM in 100 years? I don't know. I hope science will give us also here an answer for this question. Yeah, I hope you could gain a little insight how we manage our engineering structures, and I'm available for questions. Thank you for your attention.